Let's go through LeetCode 3154. Find the numbers or ways to reach the case stair. For this question, if you give us an integer nums k, and let's find how many ways to reach the stairs at a layer k. And then there is two jump rules. Actually, two operations and rules, right? So that means that at the beginning, you are at the stair 1, and the lowest stair is 0, right? So that is you cut two options. One is go to stair I minus 1. But for this stair I minus 1, that means you have to use the second operation, right? We say this operation index 0, you have to go to operation index 1 if you use for the next round, right? And the second option is that you go to this kind of 2 to the power jump position. And after this jump is turning into jump plus 1. So what we're thinking about is that for every user, right, he has 3 states. One is at a stair, for example, position current, right? And the current, and also another state is current jump. This kind of jump to the power jump. And the third is that what kind of operations he has used, right? So we use three so one state we have 3 parameters to represent. Well, say this kind of data has 10 to the power 9, right? But the things that we'll see, every time you use the 2 jump, right? You will always jump to power jump plus 1, right? And also, we'll say this kind of is exponential, right? And also the things that if we are in a position, if we have an that is greater than k k plus 1, right? That means we cannot we should terminate. Because this kind of power exponential features, so the things that we cannot go. So a lot of the paths, right, should be terminated, should be trimmed, right? So what we think about is that we can use DFS plus memo, right? So DFS will have the positions and also jump, right? And also we need to have K and operations, right? And also let's have a memo. So memo, we know it need 3 states. That is current position and jump and operation we did a moment ago for the last round, right? So so we do add this kind of result to our DFS is return how many methods we reach K, right, in this kind of states. And also just with DFS return DFS for the initial state, right? Initial state will say because he can jump downstairs or use type 2 options, we can consider the operation he did is just operation 1, right? So let's write code for this. We'll say we're going to use some string, okay? Because we need to, of course, you can use let's use string for the for the key. And for the key, right, we're going to concatenate as the position. For example, use position and jump and the last operations, right? So we use string concatenate of these three fields. And the value is how many at this state, how many ways we go to stair k, right? So we return DFS. We should have k, right? K is here, and initially at stage 0, 1, right? And the jump is 0, and also we'll say the previous operation, let's say it is 1, and the mem, right? So private int DFS int k into current position, right? Into jump and int k into operation, right? And also map string integer mem. So one thing is that if this position is greater than k plus 1, right? So we will never reach k, we just return 0, right? So we'll have a string key equals current. First of all, let's have concatenate plus jump plus up, right? So we'll say if memo contains key, we just return memo get key, right? Return memo get key. Otherwise, we will have int result. Here the thing is that because we'll say someone will say if current equals k, right? And we'll have return 1. This is not correct, right? Because at this position, he can still move, right? So we'll have int result equals to 0. We'll have result plus equal to 1, right? And we still need to do DFS after this. So we can write like something result equals current equals k or not, is k is 1 and 0, right? And say if ops is equal to 1, the previous round is jump to put to the power jump operation, and also current position is greater than 1. Then we should have the options to move 1 step down, right? So result should have plus equal to that's the current k in the current minus 1 jump 0. That means we are now operate the first operations, right? Memo. And this kind of two this kind of operation should always we are always be able to jump to the jump plus 1, right, for the next one. Okay, current, so 2 to the power jump, that is actually we can write as 1 left shift jump, and next will be jump plus 1, and this is 1 operation, right? Memo. And then we have memo put key result and then return result. Okay. Convert this to Python code. We are going to have map as memo, right? And we should return DFS K101 memo, right? So let's define the DFS should be K, that is an integer, right? That is our target. And current is our current position is also int, right? And the jump is also int. And operation, that is the last operation we did, that is also int, right? And the mem date is return int. Okay. So we'll say if current is greater than k plus 1, should return 0, right? And the key equals have this one, current jump and operations, right? So if key in memo, return memo key, right? And now we have int we have result equals 1 if current equals k, else 0, right? So I say if up equals 1 and the current greater than 0, then we have options to go to do the first operation, right? The operation 0, right? So we'll have result should plus equal to DFS k current minus 1 jump 0 memo. And in whatever, we should always have a result plus equal to DFS k current plus 1 left shift jump 1, and then we'll have jump plus 1 in operation 1 in memo, right? And we'll have memo key equals result in the return result, right? Of course, if we want to have this kind of memo, right, we can have define this as dict string dict int, something like this, right?